Hi, everyone. I'm going to talk to you today. Is my screen sharing working? Okay, hopefully it is. If
Yes,
not,
it is. Yes, it is.
great. I'm going to talk to you today about TypeScript and FHIR. So I'm Brian Kaney. There's a picture of me, and it's not too late to leave for CSHooks or publishing with Simplifier, but I'm managing everyone's expectations. That's me. And I work at a company called Vermonster. We kind of do full stack consulting, bunch of companies we've worked for recently. Maybe your company's name is here. Do a lot of work in building applications as well as doing decision support. We also partnered with Firely a while back to try and help make FHIR simpler and help them out here in the US. We're based on the East Coast. So the goal of this session is really to get people, if you're not already, excited about using TypeScript on your FHIR projects. And so a lot of that for me is developer experience or developer actually hands-on keyboard work. So I'm going to give a little bit of background, but a lot of the session is going to be typing in an editor and showing you all, if you're not familiar with how TypeScript can really help you out while you're developing code, especially when you have types that support the FHIR meta model. So TypeScript, just kind of 101, not really the point of this session, but figured it was important to just cover it at a high level. It's a syntactic superset of JavaScript. So it basically compiles down to JavaScript. It's kind of like CoffeeScript, or in some ways just using some of the newer ECMAScript versions that aren't quite available by runtime engines and using Babel to compile them down. So TypeScript is kind of that sort of thing. One of its big things is adding type support to JavaScript that doesn't have really the strong type system that you see in some other language stacks. And it's backed by Microsoft. It's been around for a decent amount of time, and it's pretty popular. The type definitions themselves, because it's kind of in the JavaScript ecosystem, some NPM modules actually ship with their own TypeScript definitions and interfaces and things. And then there are other modules, node packages that are very popular that don't. And there's a kind of a integral piece of the TypeScript community is this thing called Definitely Typed. Definitely Typed is, if you search for it online, it's kind of this big project that allows for third parties to create type definitions for existing node modules. And then when you use the two together, like for instance, if you npm install React and you npm install the types for React, you have a nice setup that allows you to have type support for the React library. And there's a lot of npm packages that are like this. And if you go to npmjs.com, sometimes you'll see a little square with a DT. This means it's definitely typed. Sometimes it'll be a TS, which means that the TypeScript support's built into the package itself. Let's see. Why FHIR plus TypeScript? I'm hearing someone coming off mute. I'm not sure if that's a question. Otherwise, I'll just keep going. I see a hand up from Sean. Marco, I forgot. Are we waiting to the end for questions? I think we are.
Yeah, I think that is the best. Or
so Sean,
if it's a really...
I would just recommend typing it into Hoover, and I'll try and get to them at the end. Hopefully, I'm not misspeaking, unless that's what that hand was.
It's okay.
So why FHIR plus TypeScript? One of the big things is the FHIR meta model is pretty big. There's a lot of types, primitive types built in, and types on top of types, and then resource types themselves, which are composed of all the pieces underneath. And so TypeScript's does add a layer if you're just regular ECMAScript JavaScript developer. A lot of times developers who are used to that don't think about types or don't need to, and they write perfectly wonderful code. But I work on a team where we have people who may not intimately know the FHIR meta model, and adding type support allows them to kind of make less mistakes and also provide some contextual documentation as you're writing your code. The second thing is just, I guess, generally developer happiness. You can catch a lot of problems in your code before you even try running it, even if you're doing test-driven development. Just by in your browser or before the tests even run, when the compilation happens, it'll warn you up front if, for instance, you're passing a codable concept into something that you're expecting a coding. I'm sure all of you probably know the exact differences between codable concept codings and codes, but for those of you who don't, TypeScript kind of provides some of that type guarding and support and documentation for you. So FHIR, there were a few efforts before to create a type library for FHIR. And I think up until not that long ago, there was a single version. I think it was STU3 available at Definitely Typed at type/FHIR. And so what we did, with a lot of thanks to the, I see Gino's on, Microsoft FHIR CodeGen project, was we used that generator because I was about to build my own. I'm sure a lot of you maybe have built your own type generator from FHIR, from the FHIR spec. But I was able to kind of work on this project and use the output of this project. And I wrote a program that packages that up and ships it out to Definitely Typed. So now we have R2, R3, and R4 all available right now on Definitely Typed. And I'm just going to quickly show, this is the, oops, sorry, I should bring up the web page first. This is the project I was referring to, this FHIR CodeGen project, and it's a .NET C# project, but its purpose is to output types into all sorts of different languages. And as you can see, TypeScript is one of them. And so I worked on this or I didn't work on this. I had a very modest, I think, pull request that got accepted, but I use this to help package up these types. And so if you don't have .NET installed, I use ASDF. I'm on a Mac, but if you do, then all you need is access to .NET. You can build the library, and then my favorite command that I use for this, in the help is listed on the website here. You can see like what all the options are, but for me, for building TypeScript, I run this command. So basically it's the command on the website. I'm asking just for TypeScript, and the export types that I find most useful. I mean, you can generate a lot and your TypeScript files get huge, but I kind of limit it to these types, which you can kind of see here what the options are. And when I run that, it takes a few seconds, and this actually generates types for R2, R3, R4, and R5. And so I kind of use this as a big stepping point, and published out to Definitely Typed FHIR. And as you can see, as of 9 days ago, we have R2, R3, and R4 all available in different namespaces, which I'll get into in some examples in a few minutes. That now the community and we can all use. The other thing is just to note is that when we created this, we made it clear, and there's a tight relationship between Definitely Typed definitions and NPM packages themselves. But in our case, we're not trying to track types FHIR to any particular NPM package. We're saying this is a non-NPM package. In our case, we're following the HL7 specification, not tracking to a specific node module. So let me get back to my slides. The other thing that's that's key to having fun using TypeScript is to make sure you have an editor or a IDE or a development environment that's able to use the type definitions. kind of one of the main de factos that a lot of people use today is Microsoft Visual Studio Code, which is a cross-platform editor. It's actually written in TypeScript itself, and I think is an Electron app, just like Atom and Sublime was, although those weren't written in TypeScript. And it is a very popular, lots of plugins. I'm going to be using Visual Studio Code to demonstrate things here. But my main development situation is I use NeoVim with this plugin that gives me full type support. And there's lots of other editors out there that support the language server protocol, which is the underlying thing, also a Microsoft effort that provides like the IntelliSense or the kind of integration with your editor with this kind of protocol to support all the fancy stuff that you get in your editor. So I'm going to go through a couple examples now, and I'm going to show like actual writing code to demonstrate and show how these types could be used. So just in all transparency, I'm starting, this is a blank repo. At the end of this session, I'll give a link to a GitHub project that has all this stuff. So for my first exercise, we're gonna work on the $extract operation. And so I'm going to, this is, just a tiny bit of background. This, oops, this is in full screen. This is a common thing to deal with questionnaires, to be able to pull information out of a questionnaire response and form that into like in our case, I'm going to show the most simple use case, which is to pull it out into a list of observations. So we're going to implement this kind of $extract operation that takes a questionnaire response and outputs a bunch of a bundle of observations. And so how I'll start that is I'm first going to install a couple of requirements. So I'm going to npm init first. Let's call it exercise 1. This stuff doesn't really matter. And then what I'm going to do is I'm going to install a couple of dependencies that I need right off the gate. So the first thing I'm going to install is Typescript. And then I'm going to install a bunch of types. So I'm going to install types node. This is just kind of a requirement because I'm running TS node. So instead of having a full like app, I'm just going to use a command line tool to run the TypeScript files, which behind the scenes compiles to JavaScript and then runs it in Node. It's kind of a wrapper that allows me to kind of expedite that. I'm also going to install types FHIR. So that's the actual thing that we were just talking about. And I'm going to install TypeScript itself. So these are, and the big D is developer dependencies. And then just looking ahead, I know I'm going to need this. I'm going to install UUID4 because for my example, I need to create UIDs. So far, this is probably a pretty typical looking project with not too much going on. So I'm going to create a file in here. I'll just call it example.ts. So actually, I'm going to have an example. This is going to be extract.ts. So this is going to be my program that I do my actual extraction. And so if I start typing this, oops, let's launch code here. For some reason it was hung. So I'm going to create a method called extract, and the parameters I'm going to take in following the spec is a questionnaire response. And here's where I can start defining what it is. So I want to say that's a FHIR 4 questionnaire response. And as you can see right here, I'm seeing some benefits of TypeScript. So not only do I have kind of an autocomplete, I'm in my FHIR 4 namespace, I'm starting to type QU and I can see all the different things in the that match. And then as I go through and look at them, I get additional documentation. And this is all directly from the FHIR spec that was compiled into the types. So right now, this is providing some value. As a developer, I don't have to misspell something, or if I'm a little bit unclear the difference between an item or an item answer type, I can look through here and see exactly what that is. And so that's kind of the input signature according to the spec. And again, the spec, if I look at the artifacts, I can see what the actual operation is. If I find the operation section, you can see extract takes in a questionnaire response, and the out is either a bundle, in our case, it can be an individual resource, but I'm going to shortcut this and say it's always a bundle, or an operation outcome. And so my signature of my method is this. And now if I want to say what needs to be returned, I can do that. And I could say this is, in our case, it's going to be a FHIR 4 bundle. And so it's underlining in red. So it's, and it's doing that because right now my implementation does not, in fact, return anything. So the type system is saying, hey, you're supposed to return an R4 bundle, but you're not actually returning anything. Now I could type in a trivial implementation. And I could say my resource type. And by the way, this this auto completion is all wired up because it knows that by the definition of the function, I'm expecting to return a R4 bundle type. It implicitly knows that as I'm returning something, this should be in that shape. So it immediately gives me the ability to kind of auto-complete that for me. Now you might be wondering, why is this giving me an error? Well, according to the R4 types, bundle is missing a type. So if I look at the spec, the type parameter is required for bundle. I don't have type here, so it's complaining about that. So I can go ahead and start typing the word type. And as you can see, as I start typing the word type, not only do I know what the type means, but this also gives me an enumeration of the kind of types that would be necessary. So in this case, I don't have to go to the documentation. I can see, oh, yeah, transaction is one of them. And in our case, according to the SDC spec, it is supposed to be a transaction, in fact. So, and then as you can see, as I start to type in the actual answer of the type, I get this nice list here in my editor that can tell me that it's a transaction. And now my trivial implementation of extract is done. It actually doesn't do anything, obviously. And you can even see my editor's telling me in this kind of grayed out, area that questionnaire response is declared but never read. So it gives you that information as well. But as far as the ins and outs of the code, this actually is the types would compile. And so I can go ahead and compile this, or in my case, I'm just going to run it. So as you can see, I have my extract. I'm just going to run. Oops, I think I forgot the .ts. Well, I'm not printing anything out, but it's not complaining. Whereas if I screwed something up and put in the wrong kind of value there, not only does my editor tell me there's something wrong, but my build system will also tell me that there's something wrong. So I'll move that back. So I'm going to go ahead and do some fast coding now, i.e. copy and paste from code I already wrote. And as you can see, my extract operation, R4 bundle, questionnaire response, it's doing a bit more, but it is returning generally the same thing. And the big thing that I'm doing implementation-wise here is I'm including these bundle entries that I'm building up. And so as you can see, I needed the bundle according to the spec. I want to get a list of observations because I'm doing the observational method of extract. I want to build a bunch of observations from the questionnaire response items themselves and following the instructions on the on the web page. Oops. I forgot to add the types review ID for. Sorry. So again, I'll make this available. I'm not going to have time probably to go through everything, but one of the other items on here I wanted to kind of point out was this this idea of a TypePredicate Guard in TypeScript speak. And so in this case, a lot of times in FHIR we have kind of polymorphism, meaning that a method or a function or an operation might return A or B. And many times we have operation outcome or bundle. Or if we're looking in a bundle and we want to look at the items in the bundle, each item's resource might be of a different kind. And so TypeScript has a way to generally ask if something, does it fit into this, is it this kind of thing? And so in this case, I have a little function here called isQuestionnaire. It takes in a generic resource, but I'm just saying it takes in some resource. I'm saying resource is questionnaire if this returns true. In the case of FHIR, you can almost auto-generate all of these TypePredicate guards. There's only a few cases where I had to, where you have to kind of put your own code in. But for the most part, you just look at the resource type parameter. And in the case of resource type being questionnaire, we know that it's the resource is a questionnaire. And so this is used right here. And I'll just move some space down here. So what we're doing here is I'm looking at the contained. So in this case, I'm assuming that the questionnaire is contained in the questionnaire response. And so but this method is more general. This is saying any resource that I pass in, find the contained item whose resource type is questionnaire, is a questionnaire. And it's a little academic because I'm already doing the type check here. But what I wanted to demonstrate is if I look at this contained response, it's actually it doesn't know it knows it's a FHIR resource, but it doesn't know it's an actual questionnaire. And so by adding this type guard, and I can kind of spell it out a little bit. And I know I misspelled that. I'll fix that in a second. At least I think I'll fix it in a second. Now in the positive condition, in the case that it's true, you could see it's aware now from my type system. It knows that the resource is in fact a questionnaire at this point. And in the else case, it thinks it's a domain. It doesn't know it's a questionnaire. So this just has the subset of things that are on domain resource. This is a very common pattern that we use a lot, these TypePredicate guards, to be able to write little functions that tell us that allow us to take, again, operation outcome responses or operation responses more generally, or looking through items in a bundle is another big use case of this sort of thing, where we want to see what kind of resource it is. So anyway, again, I will, I'll share this code later, but kind of walking through it, I'm first looking at the questionnaire response, and I'm creating basically a flat mapping, which in this case I'm using reduce, to just a list of observations. Then I loop around all the observations and I build my actual FHIR bundle entry array, which then later gets assigned down here to my entry property of my bundle. And so kind of where the little bit of the magic is, I first pull out the questionnaire that's contained in my questionnaire response. Now, if you're writing this code for real, it might be a reference to a questionnaire, or maybe you get the questionnaire some other way. But in this case, I'm assuming it's contained. The observations, I'm looping around all the questionnaire response items, and I'm getting a list of observations back. And the reason why I'm flat mapping is because turns out sometimes you can repeat answers to questions. Like if you answer the same question 3 times, the spec says you should get 3 observations that gets extracted from that. So there's a little bit of like extra looping and stuff to go around, which you'll probably find in FHIR if you deal, especially if you deal with questionnaires. And so this is grabbing the questionnaire item. I wrote a little method getting it by the link ID. So I get the link ID every time I'm going around. I pull out the questionnaire item, and then I extract the observations from the questionnaire item using the kind of the SPLA operator to kind of push it into this array, and then this array becomes of observations, which is used down here. So if I look at this extract observation from questionnaire, you can see I'm using the type system to say, okay, give me the pair of questionnaire response item and questionnaire item that correspond, because the spec says, as I'm building the answers, I have to look at the questionnaire item's code to add that as the observations coding, whereas the value comes from what the user typed in the questionnaire response. So you need the pair. You need to know both. You need to know facts about the questionnaire item as well as the questionnaire response item. And this kind of marries the two together. Now, the one thing that's really tough in FHIR is that you have this idea of like these value type choices: value Boolean, value coding, value string, so on and so forth. You know, this is new, and maybe we add this to the official type library, but I created this just inline type called FHIR value, knowing, just looking at the spec around all these different kinds of answers and things. This is kind of what types they could be. It could be string, Boolean, number, attachment, coding, quantity, or reference. I wrote this function to kind of go through that. I had Boolean last because false is falsy and would have skipped, and you get undefined. So look out for standard falsy versus actual false and true in Boolean cases. But another thing is, like, if you didn't know that, one thing you can do as a developer is I could say, okay, well, I kind of want to see what this is all about. So I can go to the type definition of answer, and this goes to the actual R4 definition file for what a questionnaire response answer is. And so I can look through here now, and I can see what all the different type, you know, as far as the type definitions go. Again, this is programmatically built from the FHIR spec itself. I can go in there and I can see what that is. And as you can see, the response item actually has, can have nested other response items. So there's that nested structure, which I didn't account for in my extract operation, but if you're doing this for real, you would, and so on and so forth. So that's pretty nice too. So anything in the system, I can actually look at the type definition and I can get more information. In the case it's an interface itself, I can just go to the definition, and this tells me what the questionnaire is. So this is the code, and I'm just going to add another file called examples. I'm probably gonna have to go a little faster through the next ones looking at the time. So in this case, I'm just oops, oh man, I put that in the wrong directory. This is why I'm not usually a VS coder. So with Vim, I wouldn't make that mistake. Okay, so here's my questionnaire. Has 2 questions: hemoglobin with link, blah, 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 and some fake Boolean thing. In this case, I'm creating a questionnaire response with a contained resource that's the questionnaire. And again, as I type this out, I can, it gives me all the typing that we saw before. I don't want to kind of beat a dead horse with that, but that's very helpful. And if I'm missing, like if I misspell one of the things that's required, such as link ID, I get that sort of problem. In this case, I'm answering question A twice, 1 true, 1 false. I guess, you know, that's a, oh, yes and no sort of thing. And then B, I'm answering with 4, my A1C value. So if I save that, I can go ahead and run that. And if everything works, oh, which it didn't. Oh, you know, I forgot to put in my tsconfig file. So I'll just do that. That's one thing I missed at the beginning. So tsconfig, because of TS node, it makes some assumptions that I need to clear out. So I can get into this afterwards. I don't have time to get into it now, but I want to kind of remove some of the defaults that TS-node uses, including some of the things around oops, what am I missing here? Oh, it's UUID. It is UUID4. I was wrong. Okay. Live coding. Okay, so this actually now shows my extract is now exporting a bundle with 3 observations in it. 2 from the first question, which I answered true and false, and 1 from the last one. So that's kind of a quick way that, and hopefully that demonstrates some of the power of using TypeScript. The next example I wanted to go through was kind of quickly letting you know that we spent some time doing some types for CSHooks. And so lots of people during the conference have done talks on CSHooks. I think there's one going on right now. It's very exciting to me, especially doing decision support. And what we did quickly is we have this library. We haven't put it to definitely type yet, but this gives us types for 2 things that we thought were useful for us anyway. One is in Smart, which gives us types for the launch context. So if you're familiar with how Smart works, you get like an object back called launch context that has your access token in it and a bunch of other things in it. So this gives us type support for that. And we also use this app styling. To be honest with you, I've never used app styling on an app, but just for completeness, I thought it was interesting. And so we included the interface for app styling as well. And if you don't know the Smart spec, this is probably meaningless to you, but if you do, you might find it useful. And then in addition, we also built, which I think is more useful for us anyway, is type support for CSHooks. And so if we start down here at the bottom, we have discovery response, which are services. Services are defined here. And so what we did is we basically took the spec, including the documentation from the spec, and included this TypeScript library. And this gives you the ability to create a CSHooks app pretty quickly, both if you're kind of calling a CSHooks service, because it has the request as well as the response, or an app that's like a CSHooks app that's displaying cards to users. One room for future improvement could be to have types for each of the different kinds of hooks. There's a bunch of different kinds of hooks that have different requirements as far as what you pass in for context. We didn't get that far. This is just more generic, but you could certainly see that coming in the future. And just to show you an example of that code, and at this point, I'm not going to write the code because I don't have time, but I'm going to bring it up here so you can see it. And this is something that you can do on your own. This uses Fastify, which is kind of a new version of, well, it's a replacement for Express, since Express hasn't really gotten the love recently as it used to. But effectively, it's a REST server. It's really nice. I recommend checking it out, even if you if that's the only thing you take. And this has TypeScript support built in. And as you can see, I've created an endpoint for the CDS services discovery endpoint. And as I'm describing this as a CS discovery response using the types that I just showed you, if I'm missing a type, my type library tells me right away. And the other thing that's kind of cool, just like before, is the hook. I'm sorry, this isn't the response. The indicator is typed, so I can know, like, when I return my cards back. This gives me from the spec the list of values for that. the hook isn't because even though there's a hook catalog, you could come up with your own hooks. So that's not strictly part of the spec. And so this is just simply making a CDS services endpoint. And then you can see the CSHooks response types used here to create a response with some cards in it. Not going to have time, I don't think, to show, well, maybe I have time to show this in action. So if I go to my browser, and in this case, I'm going to cheat and go to my my already filled out ones. So this is basically what we're just looking at. I can run my my server, which if you download this repo, you'll see I'm just using, in this case, I am using the official TypeScript thing to run the service, and I'm using nodemon to, like, as files change, it kind of automatically redoes everything on disk. But as you can see here, this is a pretty, this isn't that many dependencies to create a CDS, a smart app rather. So now if I go to, I should memorize the try it. I always do it this way, sandbox.cshooks.org. I can add my service, which you've probably seen these sorts of things before. I don't know why that's not working. Sorry about that. This was working. Let's just quickly see if I did something wrong. I don't know why this is all of a sudden not working for me. I'm going to move away from this. This was working. Yeah, I don't know why. I missed the course thing, which is a problem I had before. Here's the course thing. Okay, I'll have to get back to you on this, or you can try it locally. This was working earlier today. Trust, you don't have to trust me, but it was. I don't know why I'm getting a thing blocking it today, but that's usually what would happen. I'll get back to that if we have time at the end to see if I can figure out why that's not working. Okay, the last thing I wanted to talk about was kind of connecting to a server. And in this case, I'm using a library that we maintain, although you could use the smart one as well. The one that we have is called Firekit Client. And it has a whole bunch of features that I like. It's a little bit lower level. It's not doing as much with the kind of smart handling. In fact, you would have to do your own OAuth thing, but it does let you do things in kind of it has we developed this way back when there wasn't really a production alternative, and now you have a bunch of options, which is great for the community. But we did add TypeScript support to this. The client itself is agnostic to the version of FHIR, but I wanted to show here how you can, in fact, I'll just go through the code here since I only have a few minutes left, but the example 3 in the repo that I'll show you at the end of the slide deck uses, again, that TypePredicate Guard to be able to kind of, in our case, if I read the result and I don't know if it's an operation outcome or if it actually is a patient, in this case, I'm using the TypePredicate Guard to see if it is an R4, if the resource coming back is a patient, or if it was an operation outcome error. And so this is kind of the pattern that we landed on. This gives us all the typing support of how you deal with the client API itself, but then you would bring your own types, in this case FHIR, to deal with the responses. This is kind of early work in progress, so if people use this pattern and find out it's no good and there's a better way to do it, be certainly open to changing it. And just to kind of show code from that, that is running locally here. Hopefully this one works. I'm just connecting to happy and I'm pulling this patient back. And in this case, the patient at this point, it actually knows it's a patient. And it does that again because of that TypePredicate Guard. So at this point in my code, this is an actual patient because it's in the true clause of my conditional. And so if I run this with any luck, yeah, so I get this is the patient back from that happy test server for that ID. But this is the less interesting part. This is the more interesting part for me in that this is a typed response that's a kind of patient. So anyway, I guess I will go back to my slides, which I think we're close to the end. So all the codes here, DevDays 2021, Monster Git repo, I can put that into the chat as well, which I think would be useful. But yeah, I know we're close to time, but I guess I can look to see if there's questions here.
Yeah, there are some questions, Brian. Thank you, by the way. A lot of positive reactions in the chat as well. Like your session very much. I will ask you questions in order of votes.
Okay.
The first one is from Josh Mandel. Thanks, Brian. It's a great story for inline documentation and type checking correctness. Do you have any advice about how to determine at runtime whether an input value actually fits a given type, like questionnaire response?
Yeah, I mean, TypeScript is obviously at build time, so it's not at runtime. So TypeScript doesn't help you there. You know, I think one of the things that if you're using Fastify is the middle example I showed with CSHooks, and Fastify, if you don't know, definitely check it out. It has built-in support to kind of, has like this middleware approach. It actually reminds me a little bit more of how Ruby on Rails did it. But you can put into it kind of JSON schema checking. So as you can see, let's see if I can find the documentation real quick. Yeah, the validations here. So the validation concept here is really cool. You can create a schema, and then in the request, you can put that in the middleware, and it can validate. So one option that we're starting to use right now, since we've just recently switched to Fastify, is to include, create, or have the JSON schema in place so that we can validate. Again, that works if you have like if you're using Fastify and you're building like a server or like something that responds to an API, like a RESTful endpoint. I guess otherwise you can use JSON schema. Now, I think a future direction of both this and this, the TypeScript topic, it would be really nice to be able to easily or quickly create types for custom profiles. I know others have talked about that in other sessions, but I think you need these building blocks of just general FHIR TypeScript support before you can tackle that.
Okay. The next one is from Matthew. This might be a separate concern or project, but any word on adding a definitely typed for FHIR.js? It fits in natural to a lot of TypeScript FHIR projects.
I think there's probably people on the call here that work directly or collaborators of FHIR. I think that would be a good idea. You could, there's a lot of tools that you can actually generate the type definitions from the code. It does introspection. So that shouldn't be a big lift, at least to start having basic support. But yeah, you should definitely reach out to some of the go to the GitHub website that's pretty actively maintained. That would be something, or do a pull request and try and add it yourself.
Yeah, I think he also, Joshua also suggests that. Another question from Josh: are you open to supporting a browser-based smart OAuth flow in Firekit?
Yeah, we do. In fact, we have tons of examples of that. It's just we didn't replace, like we're using regular OAuth. So if we, look here in this examples directory, we have examples of the standalone, the public, confidential, and CSHooks. And so if you look at like the standalone, this isn't TypeScript. We haven't upgraded this yet, but as you can see here, this requires using OAuth 2, and in our case, this is an express version. But the big thing is we defer to simple OAuth 2, and then when you start Firekit Client, you can either use it in middleware, or in this case, it's just a more simple example. But you can effectively, the only thing you really have to do is set the bearer token. And you can set the bearer token directly pretty easily with Firekit Client, just like this. So once you have that bearer token, and if it's there, it supports it. And then the other thing that we support out of the box is the discovery of the well-known address, and we kind of do something very similar to the way the smart FHIR client works. We attempt at the same time looking for well-known smart configuration as well as the OpenID configuration to get back the information to kind of support that. And that's kind of all in this kind of helper smart auth metadata function.
Question from Brian, also a question from me. How do you handle extensions in this structure? I was also wondering that.
Well, because extensions are part of the spec, you can, they kind of just follow the types. I mean, you have to, I guess I'm not exactly clear on what you mean by handle extensions. The types themselves, support extensions, because if we go down eventually to, I forgot, right here on the domain resource, you can see extension is supported, and most of the resources extend from domain resource, and extension is an array of extensions, and extension itself has a has type definitions. So this works with extensions. It has, because it's part of the FHIR spec. This and the definitely type thing, we literally took the work Gino did and kind of packaged it up, and then we built a program that basically downloaded all the examples in the FHIR specs and programmatically wrote these tests. And these tests are huge. This is every example every example in the spec, and we just made sure the types work with it. And we found a few small errors, especially with questionnaires in R3, but for the most part, that all works. And there's lots of cases of examples with extensions in them. So yeah, I mean, it kind of just works, I guess.
See a hand from Gino there.
I don't see anything because I'm looking at my screen. Gino, I don't even know what I'm doing at this point. Okay. Gino has his hand up. Where am I looking for a hand?
In Zoom.
This is your job, Marco. You're the moderator.
Yeah, you can open. Yeah, you can open your mic if you want, Gino.
Yeah, everyone open up their mics. I don't.
There we go. I couldn't unmute, so.
Oh, that's right. That was a call for you. Just open up your mic.
Yeah, no worries. Yeah, so the extensions do show up just kind of as that extension type, and primitives all have a paired element that they can use to use the extensions. We haven't added any of the nice extension add remove type things that are available in other toolkits yet. So those are the kinds of things that we look towards adding in the future.
Right. Thanks.
And maybe the last question on Hoofa. Is it only type? For example, can I use it as an object? In other words, can I do a new questionnaire response? That's a question.
Well, you can make right. So you could you can make I can say I can say it's a FHIR questionnaire response, and then I can start building that object, and this object won't be valid unless there are certain things that are set. I think you also need a status, right? And then that's a valid, that's, as far as the type system's concerned, that's a valid one. So this is how you make a new, so my Q variable here is a type of questionnaire response.
All right.
So I guess it's creating a new object with this type is how this is set up to work. You can extend types, just like there's a whole bunch of stuff we're not going to have time to get into, but you can extend types, or you could, you know, if you wanted to make your own type of questionnaire subtype or something. Maybe that's how we tackle profiling.
Okay, I think our time is up. It's 5 minutes past. And
yeah, I would urge you to do feedback. So I want to keep, I'm hoping we keep people always doing TypeScript, JavaScript, ECMAScript type talks at DevDays, because I think it's a big part of the community, and I'm happy that we got some good attendance, and I hope to see you all sometime in the future.
Thank you very much.